Hello everyone, I'm Preeti Young from Team 205 and in this video we are going to see about a project named Decentralized Medical Records Management System. And our agenda for this project include introduction and statement of the problem, scope of our project, methodology we use to create a project like architecture diagram, flow diagram, use case diagram, class diagram, algorithm use, implementation of the project, and important code segments. And finally, we are going to see about the output, test cases we use to test our code, conclusions, and sustainable development goals, future work, and references we use to create this project. Overview of the increasing demand for secure, decentralized healthcare solution. And traditional healthcare systems are often centralized, posing risk of data breaches and unauthorized access. And we use blockchain technology to mitigate this risk. It can provide secure alternative, patient-centered control over data. Our project utilizes Ethereum blockchain and IPFS for decentralized storage to enhance data security. We focus on granting patients control over their own medical data. Statement of the problem. Centralized databases pose a great risk of security breaches and data theft. Limited patient control over medical data access and privacy. High dependency on healthcare providers for record management. Challenges in data integrity and consistency across healthcare systems. In this project, we address these issues through a decentralized blockchain based system. Scope of the project. Our objective is to develop a secure, decentralized medical records management system using blockchain. Our target audience are healthcare providers, patients, and medical institutions seeking enhanced data privacy. Our primary goal is to enable patient control over access to their medical data and to ensure data privacy through decentralized, tamper proof storage, to reduce reliance on centralized data storage solutions, minimizing security risks. Our key technology we used in this project are Ethereum blockchain for immutable access logs, IPFS for secure decentralized file storage, and React.js for intuitive and accessible user interface. Our inclusions in this project are data storage, medical records stored in IPFS with unique hash references and access control. Patients can grant or revoke access permissions through smart contracts. Data integrity, secure storage using blockchain to maintain data immutability. Patient interface, React.js based interface for develop managing data access integrated with MetaMask. Or exclusions or real-time monitoring. This project does not provide a continuous healthcare monitoring, comprehensive medical history. Not all types of health data are included in this current scope. Direct diagnosis features. The system does not include diagnostic tools or medical AI. Limitations of project are scalability constraints. Blockchain is usually limited by the capacity to handle large user bases. Data volume limitations. IPF is used for document storage, but larger files could present challenges. Dependency on internet access. Requires stable internet connection for MetaMask and IPFS interactions. Future considerations. Explore integration with AI for personalized health insights, enhance system scalability, and improve loading handling capacity. Broaden the scope to include interoperability with existing electronic healthcare management systems. Our methodology or system architecture. For this, we used Ethereum blockchain, which manages transaction records access permissions immutably. And we also use IPFS, which stores medical records as distributed tamper-proof files. For front-end development, we use React.js, which is used to build user interface accessible to patients and providers. And we integrated MetaMask that ensured secure access and user verification. We also developed a smart contract written in Solidity to handle permissions and data access on an Ethereum. Finally, we tested and validated our code using extensive testing to verify data integrity and managing permissions securely. System validation to ensure IPFS and blockchain interaction. And this is the workflow. First, patients upload their medical records stored on IPFS with a unique hash. The hash is logged onto the blockchain via smart contract, establishing data integrity. And step 3, Patients use MetaMask to control and manage access permissions to their records. And finally, authorized providers retrieve records from IPFS verified by blockchain for access. The tools we used in this are Hardhat, Web3.js, and IPFS client. And this is the architecture for our project. This is how the flow of a project and how the whole then our project will work using MetaMask, smart contract, and IPFS. And this is the use case diagram for our project. This diagram will show how actions of a patient can perform with the system and focus on data management and access permissions. And this is the use case diagram in view of the healthcare provider, how they request access and view their granted accesses. And this is the class diagram of our project, which the detailed data on each class like patient, healthcare provider, user interface, Ethereum smart contracts, blockchain network, and IPFS storage. And this is the sequence diagram for our project. The algorithms used in a project are role-based access control, or also known as RBAC. Smart contracts use implement RBAC to manage permissions based on the user's role. Example: patient, healthcare provider, etc. And access logging. Transactions are logged immutably on the blockchain to track access history and ensure transparency. These are the smart contract algorithms. And for IPFS encryption, medical records stored in IPFS are encrypted to prevent unauthorized access. And we also use data hashing. Each file is hashed in generating a unique identifier to ensure data integrity and avoid duplication. Blockchain based permission management. The permission grant or revoke functions, the immutable ledger, these are the things we use for blockchain based permission management. Hardware requirements. The user devices require 64-bit OS such as Windows 10, Mac OS, or Linux with a browser supporting MetaMask extension. Server requirements. For testing purposes, any local or cloud-based Ethereum test network like Ganache or Robston. IPFS node. Optional local IPFS node for testing through IPFS public gateways like Infura or used in production. Software requirements include blockchain framework, front-end development. For blockchain framework, we use Ethereum like Hardhat and or Truffle for smart contract. For front-end development, we use React.js. The libraries are Web3.js, IPFS client, and OpenZeppelin. For authentication, we use MetaMask. And for programming languages, we use or Solidity for smart contracts and JavaScript for front-end logic. Implementation. The smart contract first the step is smart contract development. And the next step is front-end development. Third step is IPFS integration. Fourth step is testing and validation. These are the important code segments in our project. And this particular code is for the Solidity is for a smart contract using Solidity programming. And this is the index file, HTML file. These are the sample outputs after implementing our project. This particular image shows a homepage of our project. And this is the MetaMask interface of our project. And this particular page shows real-time visualization of a project, which includes the retrieved medical records. And we also use test cases. This is the test case one, and this is the test case two. For sustainable development goals, they include good health and well-being by improving security and privacy of healthcare records. It contributes to more efficient healthcare delivery. And another sustainable goal is industry innovation and infrastructure. And other goal is peace, justice, and strong institutions. Conclusion. This project provides a decentralized secure system for managing medical records. We use blockchain technology to reduce risk of data. And patients can gain control over their own healthcare data when we demonstrated the value of the blockchain in healthcare data security. Future work can be like AI integration, scalability enhancements, EHR in system integration, and data sharing for research. These are the references we use for our project. Thank you.